And right now I'm inside of a classroom. I wanted to do a live, and this is the first live I've done on YouTube in the year 2026. And clearly I'm speaking on a microphone. You can hear the sound coming through these, I believe it's in the ceiling actually. There should be some speakers in the ceiling. As you all know, there are a number of activities that I do on this YouTube channel. And one of them involves building speakers. Another involves fabricating nano electronic devices for spintronic technology research. Another one for quantum technology research. And then, well, it's usually processing related, like lithography, patterning, and so forth, etching. And then the other area is random topics like simulations for electromagnetism or permanent magnet simulations, or maybe open source tools for design generation or design, open source design scripts for, some kind of chip. I could be kind of application specific, but they're usually non-CMOS related. It could be made out of just metals and oxides, pretty much. So, or maybe some special material that's in between, not necessarily a semiconductor. Anyhow, so all of that usually we do on this kind of channel. And let me see. Oh yes, and then the other area of course is Blender simulation or Blender animations for either quantum science education or perhaps artistic ideas. Another one that I did recently actually was Python scripting, taking a somewhat of a LLM inspired Python script that is fed the syntax and the workings of Blender Python, and then running it in Blender, and then seeing how well it could generate a scenario that is likened to some kind of architectural drawing. But it's also consistent because I went to architecture school, so perhaps that is of interest to folks. I do have some friends in the architecture field, actually, who have used Blender for architecture drawing purposes, open source architecture. Because, well, there are much bigger tools out there used for architecture drawings, like Rhinoceros 3D, for example, Grasshopper, other tools like that. And they definitely cost lots of money, and the open source solution, which is Blender, could actually help alleviate the costs of such a design. People are trickling in. Hello, everyone. I'm just discussing the different modes of contribution to this YouTube channel, because I've had this YouTube channel since around about 2013, 2014, 2015 perhaps. It might be 2015. So anyhow, I was quite young at the time, and now I'm just kind of reminiscing of all the things that we have been doing on this channel as of the past 6 or 7 years. So with that in mind, I do have some things to talk about. And one of the larger topics that has come up quite often is my contribution to quantum computing hardware. So, as it turns out, folks from Wall Street, funny enough, seem to value my insight in this area. Not just because I'm working in the field of quantum computing technology on the hardware, but also because I look at it from a somewhat strategic point of view to identify the realistic bottlenecks and perhaps find some kind of solution that may work for those bottlenecks. And some of those bottlenecks, I may be working on those directly. But those publications are coming throughout this year. I may have 5 to 10 publications, and they will be available on Google Scholar later this year. And then I have a GitHub, of course, that I've talked about quite frequently on this channel called Quantum Hardware How-To, or QC Hardware How-To. That is the name of the GitHub repository. And it has actually garnered a lot of attention, and it's used arguably throughout many of the major institutions throughout the US and also outside of the US, where people are interested in studying quantum computing hardware and sort of the analog or the quantum adjacent technology for those. So that repository is very extensive and is very deep, and there's also kind of some linguistic explanation, some vocabulary, terminology breakdowns of what is going on in that area. So people are definitely interested in that, and it also kind of helps out with quantum science education. So we can combine those topics together with animations, like, with Blender, for example. So I've already done some projects on that, and I've already given lectures on that here on the channel. So my hope is to do some more of that here throughout the year. And then let me see. So, the Wall Street scenario. So I was thinking about this earlier, a couple days ago, and basically I was approached by some folks who had emailed me. They came to my office. We met and we spoke for about an hour and a half or so, and they asked me all kinds of questions about quantum computing technology. Not just the basic questions, but actually about where or what we should do with this technology, and if there are any certain solutions that should make sense. So I gave some of my insight on that, some of my inputs, and again, they were asking me questions about the repository because they told me that they had read the repository quite extensively, and they used that repository to learn more about the technology so that they could perhaps find a way to influence the quantum, the markets. Because as you may be aware, there are lots of major organizations throughout the US and other major players throughout the world who have private corporations, and those corporations have lots of money, and they want to make use of quantum computing technology, quantum networking, quantum internet, quantum sensing, and so forth, and want to take advantage of that extreme precision that you get from quantum technology, and then perhaps use it either as a product or as some kind of real solution for energy savings, for example. Because some things, doesn't matter how much computing power you throw at it, it just tends to burn up a lot of electricity, and then you got to pay for the electricity, which of course, if you have the money for, it's fine. But here, you might be contributing to the pollution in the air or something, or maybe water resources, which is one of the bigger concerns with people working in the field of AI. They got to worry about the cooling part of the technology. So one of those approaches to getting around that, working around that, is to perhaps find a use for quantum precision, and then use that to cover some of the extreme energy that would have been burned up using, say, for example, GPU servers. So it may not necessarily require the same kind of matrix solving or ray tracing or some kind of real graphic setting that is solved by the GPU, but perhaps there are some other unique problems that graphic or general purpose GPUs are pretty okay at solving, but perhaps they can be reframed mathematically to solve with some kind of analog device, either an analog processor, neural processor, some other kind of processing unit, even neuromorphic processing, and possibly even quantum processing, so that those reframed problems could be solved with those. So really, you're solving mathematics. What do you do with a quantum processor? You're taking some mathematical problem, and then you're solving it. Done. Solve it. So what does it mean? You're creating solvers. You're using solvers to solve some problem. Hence mathematical solvers. It's in the vocabulary, it's in the terminology, it's in the linguistic interpretation. Anyhow, so what does that mean? That means the bottlenecks that we do have currently, especially if we're trying to achieve maybe some fault-tolerant regime, it will give us a way, if we can identify those bottlenecks and then throw some corporate solutions at it, perhaps we can actually solve it. But I have some ideas about that, and so we spoke about it. It usually involves quantum transduction, because in order to actually scale up, you want to connect one processor to the next processor to the next one, and they're all quantum processors. Then you need some kind of quantum transduction mechanism, and also quantum memory. So you need a long-lived enough state, hence the quantum memory, and then you need to be able to use that state, and then it needs to last long enough so that you can actually transmit it using a quantum transducer, and then it could be easy to transmit through optics, photonics, I should say, maybe like a fiber optic. So that's part of the solution. So you're using quantum network solutions and then the physical hardware of those quantum network solutions to make a larger fault-tolerant quantum system more feasible. So that was some of my input. So what are those pieces that you need to put together? You need at least these two or these three, and then you need maybe some other components to make that happen. So whatever that solution may be, I have some specific ideas on those, but we will not talk about that today because we may have to write a paper on this and then have a discussion about that in the greater research and stakeholder community. So when I say stakeholder, I mean people who really want to take advantage of this technology, not the folks who are just kind of focusing on doing a little experiment and then being done with it. That's different. That's just physics research for you. But we are going beyond just studying the phenomena here. We're actually trying to take what existing knowledge we have of the technology and then actually manufacture it and architect it together so that it can do something for us that is compatible with whatever solvers that we create. By we, I mean quantum researchers, people who are really, truly invested in this in terms of personal interest and also maybe some kind of healthy obsession. At least that's the case for me. So there's a lot of theory that can go around, but really, again, it's just a lot of mathematics, mathematical physics, and so forth. You know, you can have whatever solution you want mathematically, but when it comes down to it, you will have to apply some kind of error mitigation strategy or possibly even error correction. But again, error correction really depends on hardware. So if we take a little step back, then error mitigation is what we need to use the most at the moment. So whatever solver that one could create mathematically or otherwise through some workflow needs to be compatible with error mitigation. Usually it is, but it just needs to be in the back of your mind somewhere so that when you have it ready and it's ready to be used, then you should definitely integrate that together. And then you can make the solver more robust, a lot more accurate. And then you get lots of data, and then you can clean up the data with the help of those error mitigation strategies. Before we move on to the bigger version, which is the error correction. What I'm saying is that error correction requires lots and lots of data. And consequently, that requires lots and lots of hardware and research in that area. So we're getting there. We're getting to the error correction part. And there may be some rudimentary error correction going on at the moment. But for now, we are dealing with error mitigation. And so far, that's really good progress. We've already seen so many good seminars from IBM, for example, and many other consortiums and communities that love to share the research on this. So that's good progress. But for right now, we need to focus on all areas depending on personal interest. Again, because that's the practical way to go about it. If you're trying to solve something that you don't really have an interest in, that's really difficult. You're making it difficult for yourself. So that's my advice. Anyhow, so we're moving along steadily, and well, I hope you continue to tune into the channel, because we may even find some ways to produce lecture materials at different institutions, and then those institutions we can actually broadcast it here and speak about these topics within reason, and then come up with some real serious ideas, and then implement those ideas. So that's what we're doing. That's why I have PhD work to do. Although mine is kind of more interdisciplinary, but to some extent architecture is involved, and I'm here for it. So yeah. Anyhow, thank you all for tuning in for today's live. I will likely have some folks come join me on the channel, or I might join their channel for a little bit, and we'll talk about these topics. It's going to be neat. We can talk about whatever seems interesting, really. Even linguistics topics. That's great, because I went to journalism school, and that's not where I learned linguistics. Linguistics I kind of learned on my own, but still, that is of great interest to me because of the way people communicate, the way people get information across in one way or another. There's different techniques, and there's also different techniques for sort of trying to understand what people are trying to relay in terms of information. So it's really a lot of information theory if you think about it. But regardless, there's a lot of speaking. There's even speaking techniques. There's some contribution in that area that involves information theory as well. So I think that's worth it. Studying linguistics really takes you a long way. So that's probably my other piece of advice, is if you could study the way people communicate, efficiently or otherwise, in terms of speaking, rhetoric, writing, things like that, then I think linguistics could help you a lot, for sure. Not just for computing purposes, but also for actually collaborating with other people around the world. So yes. Anyhow, thanks for tuning in. Adult Julia.